I'm quickly just sharing my screen. 1 second. Yeah. So um, this is a data science and AI learning session. I mean, I could say I'll just give you a glimpse of all the fancy terms that you're going to hear, or you're hearing a lot of those fancy terms, or like the buzzwords. What is the magic behind those, or like what is something that is that you should learn to become a real data scientist or machine learning engineer, artificial intelligence, AI engineer, Gen AI developer, prompt engineer, and a business analyst, data analyst, statistical analysis. There are a lot of buzzwords in the industry right now, and this is the most trending technology in the current IT sector, because every jobs are being automated by data science currently, like implementation of robots, beat anything. So, but there is no other new technology that came up to automate the data science process. So, as I can say, being a data science or being a data scientist who learns the pure crunch and core of the data science, their jobs are safe. I can clearly say that's one motive, or like that's a kind of a motivation that I can say your jobs are secure. But one thing, getting job is really really difficult. Like you have to put lot of effort, lot of hard work, lot of patience. Then only you can enter into this the world of data science. So I'll just show you. This is the it's a 4 week webinar. So today I'll just show you like what is the overview of the course that I'm going to tell you like what and all that are going to be covered in the paid course, not in this, but I'll just give you a glimpse of what can be achieved if you enroll for the paid course. And I'll just show you what's the importance of specific language. There are many languages like Google has Go language, and then C sharp. Microsoft has .NET, which is the C sharp, and there are Java, C++. There are a lot of languages, but why use Python for data science? And what is the importance of Python for data science? So that is something that I can tell you. Like, okay, this is how um, it will be and why you need to use Python. And I'll just quickly go on some basics and its applications in the data science mainly. So this is for this week agenda, and coming to the next 3 weeks, I'll deeply touch in them when the session actually starts. But I'll just give a glimpse. So second week, I'll tell you the in-depth of machine learning and deep learning. Why is machine learning? Why is deep learning? And what are the fundamentals of that, and what are the real life scenarios where we are using these concepts and how they have adapted these technologies to make their product much more robust, and it's giving them money. So I'll just go over some real world applications and case studies. And day three is something, I mean, the week three is something, it's purely into the NLP, where natural language processing. This is the most important part of data science, because as uh, every day we speak, we write, we hear audio. So everything is in text, everything is a language. So the processing of that language, be it in any form, is something that is the real challenging problem in a data science world. But no worries, like I'll just give you an example of what is natural language processing and what's the significance, and the techniques and tools, and then what are the hands-on exercises. NLP, I'll just give you a glimpse of those as well. And the final week, I'm going to tell you the state of the art language models. Like now you've been hearing Chat GPT and Gemini, Meta AI in your WhatsApp, and Google has formed Gemini, and OpenAI has got ChatGPT. So why can't you build something like that on your own for your own company, or how it is being built, how you can build it own, and what are the advantages in that technology, and what are the trends implications. So I'll just go over all these things in this 4 weeks of data science webinar. So please don't miss them. And if you, at the end of the day 4, if you feel interested and you want to enter into it, there is a lot to learn, guys. But we as a Kalki, we have um, worked we have worked like so much to come up within a curriculum that should be an industry ready for you guys. So we have done a really good job in that, so we can deliver that most of these parts in the 1 month training course that we are going to um, start after this 4 weeks of webinar. So this is me, Tanmay. I'm having close to 7+ years of experience into data science and machine learning. I worked for an client for Microsoft, and I worked for Bosch, and then I worked for Kerala Global Solutions, which is Anthem in US. Now I'm currently working for ADP, which is a payroll that you might have known. So I'm a I'm an MNC guy where I have worked for most of the top MNCs till now. So quickly, let's start. So any questions so far? Any questions so far? Can I take that silence as no? Good. Okay. Good. Okay. So these are the four buzzing terms in the IT industry. Like, let's say data science, artificial intelligence, machine learning, and deep learning, as I just said. So each one has its own significance. Like, the namings are different, but at the end of the day, these all combine, like the combination of all these things will do a job, one single job. So you can pick anything, like, let's say with respect to your job, you have to pick the right tech stack. Okay, so each one is interlinked to one another. So I'll just help you with some manual diagram. I'll just use paint, if I may. So 1 second. uh, Okay, so let me know you're able to see my paint, right? Good. So now let me draw a diagram. Okay, this is something that, oh, 1 second, just let me move this to here. Yeah. Okay, so this big circle, let me call this as AI. Okay, so AI is nothing but it's artificial intelligence. So uh, AI is a world basically. So it will do a job like based on the instructions. Like, let's say how a computer works based on the instruction, how a program works based on the code that we write. So the same way, we will train a robot to do some task, some specific task that human is doing. So that's called artificial intelligence. So in this artificial intelligence, let me draw in another circle. This is ML stands for machine learning. So hear me out clearly. Machine learning. So machine will learn. How the machine will learn? Machine will learn based on the data that we give, or it will train on the data. Okay, so just understand these two words: learning, training. So humans are training machines, and machine is learning. So that combination is helping the machine based to do some specific job based on its learning. So there are a lot of models in this, n number of models in this. Like let's say there are different approaches, like different techniques. Uh, like, but at the end of the day, everything is doing the same job. Like it'll see the problem statement and it will try to understand the problem and then it will do the job. How it will do the job? Based on the learning that it took from the previous data or from the previous trends, previous past, anything. So I'll just give a simple example. Movie is good and you said it's a positive review, and movie is bad and you say it's a negative review. Negative review. So like that, you have a lot of reviews data set. You feed this to an ML model. So what happens next? So tomorrow, when you give a review, this model will tell you whether this thing is a positive or negative based on the learnings it has in the data set. So that is machine learning. So machine learning is a subset of AI. Okay, so now if you see, I'll draw in one more circle. This is called DL, which is deep learning basically. Deep learning. So deep learning is something, it is a subset of ML. So for machine learning, what you have to do, you'll just give this complete data and then you'll tell, okay, this is positive, this is negative, it's fine. But you don't want your machine to just say, okay, this is what I have given you. You tell me based on the decision you have done. Based on the training that you have done or based on the learning that you have done, you gave me the decision. But deep learning, it is something that will think like a man. It will not just learn. Deep learning algorithms have neurons, axons, like how our brain has neurons inside it and axons inside it, and how they got connected. Okay, let me just put you an example in this way. So let me just give you an example. So let's say I have two hands. Okay, so now I have put my one hand in let's say in a hot water and the other hand in a cold water. So which hand you'll pick first? Like there are two tubs. One is hot water, one is cold water. So in if you keep your hand in both the hands into both the things, which one you'll get remove first? Obviously the one that we keep in the hot. Why? Because the neurons connected with your hand that you put it in the hot, it clearly gave an instruction to your mind that remove it. So that's the exact same algorithm that it's getting triggered in this deep learning. So now how many words you heard now? Let's say AI, machine learning, deep learning, 3 words you heard now. So there is something called data science. What is data science then? Data science is something, it helps all these things. This is data science. This is data science. So to solve AI, ML, deep learning, we need data science. Again, what is data science? It is a mathematics. It's the max. It's the max that we apply to do all these tasks. This is data science. Okay. Are we good so far? Any questions? Is my camera not working? One second, guys. Milan, is this recording? Or you want me to start? I don't have an option to start recording and Devashish, you there?
Yeah, Tanmay, yes, the recording is on.
Okay.
The live part is also already on, I think. So that is fine.
Okay. Sure. So, so far so good, right, guys? Everyone is fine with it. Guys, I need some reply, guys. Some motivation. Come on. It's just a morning for you guys. Oh, hello. Can someone say hi in the chat?
Hello.
Hey. Hi. Thank you. Thank you. Wait. Thank you, Palsan. I want some. Yes, all good. Thank you, Biraj. Thank you. Thanks for the reply, guys. I just want some responses. You can unmute yourself and you can ask questions. You can answer them. So, good. Okay. Let me just share my screen back.
So,
So
guys,
this.
please remember, until unless you ask the question, it should not be the learning should be interactive and interesting. Uh, it also give a trainer and us a little satisfaction that we are not, we are in the right track. We are delivering our uh, coursework, those who are really want. So even and we don't judge people, and no question is a stupid question. You came here to learn or know something new. So you can ask anything. You can share your personal profile. You can share your, personal view. You can share your personal struggle on your job market. So anything is good. And I can assure you, you don't find this kind of opportunity every day in internet or nowhere, basically. Yeah, Tanmay.
Good. So this is the diagram that I just told you guys. So this is the whole one is an AI and ML is subset of AI and DL is subset of ML. And this data science, it is something that we give and support to all these things like just a mathematics thing. So if you can see all this, these are the four concentric circuits. Like deep learning is a subset of machine learning, which is also a subset of artificial learning. So is it that interesting? Isn't it interesting, guys? So like the AI is all about the encompassing the concept that initial interrupted and then followed by MLs, and then lastly we have now deep learning models, and now we have LLM models. So starting from one point, it got elevated to a next level where now we can get everything at our fingertips. So that's the evolution that an AI had. And being a data scientist or being an AI engineer, being an ML engineer, whatever it is, you have two things in common. One, you cannot do or you cannot achieve something which is 100% sure. Firstly, you have to keep that in mind. If you are saying you can do it 100%, then it's a trash and it's a wrong. And secondly, you are not learning the complete thing. It's an everyday learning process, each and every day. Some IIT guy, some MIT guy, some NIT guy, like someone will do some research and they're going to release a paper on the uh, be it in machine learning, be it a deep learning, or be it an LLM model. So it's a continuous learning process through your lifetime. And trust me, it's very much interesting, and the salaries are quite high because of the work that we do, because it's not so easy that someone can learn this in a day or two or in a 3 days or 4 days or max to max like 10 to 15 days. It's the learning concepts itself takes you close to 1 month, and you have to work a lot each and every day remembering the concepts, how we going to do hands on, so all those things. So that's the journey of AI and data science. It's really interesting. So let me just tell you what and all each component is, and then I'll just show you samples. Okay. So now, what is artificial intelligence? So I just should know. I just like it's about giving our human intelligence to the machines. Like if you can see artificial intelligence, it can be loosely interpreted like to mean incorporating the human intelligence to the machines. That's the crux of artificial intelligence. So let's say whenever a machine completes a task, so like based on separate rules or like some instructions, we call them algorithms or not. So it followed all the instructions that we have given. It followed all the rules that it has to follow to give a decision. So everything the machine has done. So for that process that machine has done, we call that as a machine intelligent and we call it as an artificial intelligence. So the intelligence is comes artificial is like artificial thing and intelligence added to it, like how it worked based on the rules that we have told each and everything. So that is called artificial intelligence. So now let's say, for example, machines can move, manipulate objects, recognize. Like I hope you have all seen Robot 2.0 and the iRobot, which released in 23. And recently, if you have seen the Tesla's innovation and the ramp walk of all the robots, and I forgot his name. Marvin or something, his name, the robot name, and the cars, everything is AI. Elon Musk used the AI to its
Optimus.
Optimus. Yeah, thanks, Minan. So Elon Musk has used the AI potential to its core to deliver that, like something we have seen in movies. He made it real, just like that. So it's all because of the basic coding and the basics from this artificial intelligence. So now let me tell you what is machine learning. So if you see machine learning, so machine learning, there are two things. One is supervised learning and the second one is unsupervised learning. So
Okay, Tanmay, before you go to in details of it, there is a question from
yeah,
Monisha
okay, let me just
is regarding
okay.
uh, to get placed as a data scientist. Can we say what our topics could should be considered most? Monisha, you can also speak out if you want to discuss this question.
Yeah. So Manisha, as I said, to become a data scientist, we as a Kalkey, we have developed a robust curriculum. So all you have to do is like just attend regularly, listen to the classes, and do the homeworks. I think that should be sufficient for you to get all the um, um, qualifications to be an industry ready data scientist. So
No, basically, what I think she meant is that I think she is already aware of, or she has taken any, I mean, training program with some other, some from somewhere. But she is more concerned that if right now she wants to get placed, what topic should she be preparing for? I mean, is there any
yeah,
generalized?
I was coming to the same question, Devashish. So it's like, see, companies have different requirements. Some companies work only on NLP. Some companies work only on image and video data sets. So for companies using image and video data sets, if you have machine learning knowledge, you cannot be placed there. You have to know deep learning. If some companies use only text data and they don't figure it in any other type of data, so you need to know NLP. So if you don't know NLP, then you're of no use to them. So it's like machine learning, deep learning, NLP, LLM. So these are all combined. In addition to this, there are two more things like time series analysis, recommendation system. So each company, based on its domain knowledge, they'll adapt to some technology in this whole data science world. So if you know all the major things like machine learning, deep learning, NLP, and the prompt engineering, these are the four main things. I think most of the companies you will be eligible for. 99% you will be eligible for all the other companies to get shortlisted and then proceed for the interview process. If all goes good, you get selected. So, Masha, I hope I have answered your question. Yeah, thank you. So we have another question here. Admin, is this internship would given any task to complete? Don't get worried, SSM. So this is just to tell you what is it that you're going to learn. Just I wanted to give a touch base upon this is what AI is, this is what data science is. So if you get the interest, like okay, even I want to build something, even I want to achieve something. So from that perspective, if I have interest and all, we are offering a paid course, which I said like we have developed an industry ready curriculum. So in that you'll be having some tasks to complete and just some homeworks and some assignments. So that's where you'll be given any tasks. But right now it's a free webinar. You can pitch in anytime, anywhere you wanted to ask general questions, everything related to the field. It's fine for me.
So
Okay.
here I would like to add one more thing. Here our for our internship or free session, we have only 4 weekend to complete, like 4 session, and we have a mammoth size topic to cover. So here we don't have that much flexibility and timing to give task individuals to our individual uh, students and check those things. Yes, our main course or paid course, that is hands-on also, and have a live project and task oriented. You will have a your dedicated lab. But here, as there is only 4 weekend, so and every day we are going to choose one topic, because you can understand AI and data science is a huge domain. So we don't have that much time to give the individual task. Then my one more very interesting question I got, that is, you when you mentioned that every now and then there is a research is going on rigorously on AI domain. So how to get those research paper apart from Spinger, IEEE journals? Do you have any recommendation how students can go through uh, those paper AI research paperwork? Because as per my knowledge,
See,
IEEE journals and Spingers is one of the best. IEEE is one of a few. Um,
see, those will all make sense if and only if you have the knowledge. Basically, without having any knowledge, you cannot even understand the abstract of any paper or any research paper. That's the beauty of data science. Not someone from normal tech stack or something, if they go and read the abstract of it, they will not get the full meaning. But unless you are a data science guy, you are in the shoes of an actual learning curve of a data science, you'll get to know what is what. So that's the beauty of it. And it's not just IEEE or Splunk. You can get them in Reddit, and you can just normal uh, open source websites. There are a lot of there. So I'll just try to give some things like here and there based on the solutions that I'm going to teach. If required, I'll just show them. Um, it'll be an add-on thing in the training as well. So any other questions, or can I continue?
please continue. If you
So,
have any other question, I will ping you.
yeah, I just kept a tab here so I can see. Cool. So the machine learning. Let's come back. Let's come back, guys. So machine learning. Excuse me. Yeah. So machine learning is something like it's mainly of two types. Like one is supervised learning, and the second one is unsupervised learning. So uh, when you see those words, like one is supervised learning and the second one is unsupervised learning. So take those words, supervised and unsupervised, supervised and unsupervised. So this learning is purely dependent on what type of data that you're going to give. So there are n number of data. Let's say if you pick a database, you have structured data with rows, columns, what column does what is the information of that column. It's purely structured. So if you have the structured data, that's where you can go for supervised learning. And unsupervised learning is something you don't know what the data is. It's all like everything, like let's say lot of email texts, or like let's say lot of reviews, and you don't know what is what. So you just have a dump of data and you don't know what is that data, like what is it contains. Nothing, you have no information. So from that, from that type of data, we do some learning. That is unsupervised learning. So supervised learning, it's straightforward. So you have a structured data, rows, columns, everything, you know what is what, and then you just give to the model, and then the model will train. Okay, this feature does this feature does this. Okay, this is the relationship between these two features. Okay, now my values are like this. I'll stop here. Now my values are like this. Now I want to predict my next column. So if my next column is of classification, like let's say you go to a bank. I'll just give a small example. You go to a bank, you have some loan requirement, be it a personal loan or a house loan, something. Okay. So what does the bank do? They'll collect your Aadhaar card. They'll collect you. They'll collect your SSN number. I mean, in US, I don't know the exact process, but they'll collect lot of information from you, starting from basic your name to your salary, playslips, everything. So once they have everything, they'll prepare your CIBIL report. They'll get your CIBIL report, and based on the CIBIL report, they'll take a decision whether to give the loan or not to give the loan. So it's a tick mark or it's a no mark. I mean, it's an acceptance or a rejectance. So that decision, like whether to accept or whether to reject, is classification. Like to identify whether it's a man or a woman, or to identify whether, okay, this will be in this place or in that place, or to identify whether it is accept or reject. That is classification. Sometimes you have three: accept, reject, bypass. Like, I mean, like try in another way. So there are three. So it's about the classes. If you're going to keep your application in particular one bucket, that is classification. Regression means how much amount you're going to get. Based on all these things, how much amount you're going to get. Or let's say you have a land. Okay, you have square yards, SFT area, how much is SFT per area, and then your model will tell you, okay, this land will be costing around this much dollars. So something, if you are predicting a continuous variable, so that value of that land starting range from 0 to some n number, like 0.1, 0.2, like that. It's a continuous numbers. I hope you guys know what is continuous numbers are. So if your machine, if you're training a machine to give a continuous number, that is regression. Classification means it will just tell you classification. Like, I mean, you're identifying in which class this will belong. But whereas regression, it will tell you the continuous integration. Like let's say the continuous value, it can be any value. It can be any value. So that is supervised learning. Okay, so now what is unsupervised learning? So unsupervised learning means you have, let's say, okay, let me put it this way. So you have an office. So you asked your employees to get all the taxation files. Taxation files, reports, everything. You kept a box there and you ask each one of your employee to dump all your things in that. Generally this happens. So I'm just taking the real world example. So now what, let's say you are a machine, what you will do? You'll take all that whole bunch and you don't know what is what. Obviously, right? Because it's a bunch of documents. So what you will do first, you'll segregate. You're keeping all the form A forms into one, all the form B forms into one, all the rented houses receipts into one, all other proofs into one. So you're segregating them. So you take the whole bunch and you're grouping them. Clustering means grouping. So you take some data and you don't know what is it, and your machine will see the whole thing and it'll group, okay, these points belong to this group, these points belong to this group, these points belongs to this group. So you will divide your data into small groups and then you name the group. So now you are actually, because of the clustering, you're actually um, telling the unstructured data into a structured way, or something I can put it in this way. Because of the clustering, you have some classes now: class A, class B, class C, class D. So when a new file comes in, you're definitely know, okay, my class A has all this, class B has all this, class C has all this, class D has all this. So when a new file comes, you'll definitely, with an immediate action, you'll keep that file into C or D. So that's is what grouping or clustering. So guys, just remember these things: classification, regression, and clustering are the three major ideas of machine learning. So the intention of ML is also same, like it enable machines to learn by themselves using the provided data, and then it will give us accurate predictions. So depend on the predicting, what are you predicting is very much important. If you're predicting a class, or if you're predicting something between an interval of 0 to 1, then it's classification. If you're predicting a continuous variable, it's regression. If you don't know what you're predicting and then you're just grouping them, then it's clustering. So it's a simple technique, guys, for realizing what is AI, and in fact, it is a subset of AI. So this is what general ML machine learning is. So I have any question? Do your sentence certificate is applicable? Yes, you got the answer, SSM2. Okay, I have any other questions, guys? Here you can unmute yourself and you can ask. Come on, guys. Is it clear? Cool. So now, I'm just telling you an example here. If you see here, I have a weight, I have a texture, I have type of fruit. So 155 rough orange, 180 rough orange, 135 smooth apple, 110 smooth apple, 120 smooth. What is it be? So now forget about the last line. So if you give this above data to a machine, excuse me, if you give above data to a machine, it will say if the texture is rough, you have to say orange. If the texture is smooth, you have to say apple. So it has identified a pattern. Understand, guys? It has identified a pattern from the data set that you have given. And now the moment that you give smooth, it will say apple. So that's the simple logic, machine learning. That's it. Cool. Now, deep learning. As I said, deep learning is something that we use our human brain. If you see this greens, oranges, and lines connecting these, so the lines connecting these are called axons, dendrites, and these, what does axon and dendrites do in our human brain? Just a biology. They connect neurons. So these are all neurons. These are all neurons. So I'll just tell you, you have, let's say you're a kid. Okay, sorry guys. I just showed you. Okay, this is a panda. So your brain processes everything and says, okay, this is a panda. But you have a lot of pandas: red panda, Jane panda, raccoon, and you can make like side angle of panda, front angle, back angle, top angle, different pictures of pandas, and you feed your kid saying, okay, these are all pandas. And the moment you show another panda, he will say it's a panda, because the brain got learnt on all the angles of panda. The same thing goes with the dog. So that's the beauty of deep learning. So it will, there are memory cells like it's a in-depth architecture. It's a purely long short-term memory architecture. Like, because see, as I said, these are inspired by our human brains, like how information process happens in our human brain. So they have taken the same architecture and they have kept it in the robots. So just like we use our brains to identify patterns and classify various types of informations, the deep learning algorithm will also do the same thing. It's both the same. Like they just replicated our brain algorithm or the brain architecture, and they have come up with some very good models like artificial neural network, convolutional neural network, and recurrent neural network. These are the three main topics in deep learning that deals with RNN, deals with text data, and convolutional neural network deals with the video and image data, and artificial neural network deals with the normal ML data set. So this is what deep learning is. So no, I hope you have understood now. Deep learning, machine learning, and um, deep learning, machine learning, and these two are subsets of the artificial intelligence. So, good. So again, as I said, data science. Data science.
Sorry, please, can you explain the second diagram? What is the difference between the two forms of convoluted layers and the classifier and softmax? What are the difference?
These two?
Yes, like one has
No.
softmax, the other has classifier.
Okay, cool. I just because it will be too advanced for you is what I thought, but yeah, let me just tell you.
Okay.
So softmax is something that we apply some function. Like let's say you have, see, if you see here 1, 2, 3, 4, 5. If you see here 1, 2, 3, 4. So I'll just give an example. So your input has 1, 2, 3, 4, 5 layers, and your output has 4, 1, 2, 3, 4. So when you give an image, after processing everything, you'll end up with 4 outputs, 1, 2, 3, 4. So on these 4 outputs, you'll apply some function to decide what is what. Like let's say, because as I'm saying, so you have different pandas, red color panda, like there are like let's say red panda, Jane panda, there are many things. So when you think in our human brain perspective, if you think and will say one decision, the same way the machine will take this layer. Like it has many things, softmax, classifier, and then you have optimizers. There are a lot of things. So these are some mathematical algebra functions that we apply on this to get a decision. Like to make deep learning work, they'll apply some mathematical formula, and we apply something that we see, and then we try to calculate some max inside it, and then we'll say a decision. So that's the same thing. Is it fine, Oklahoma?
Yes. And classifier, is it the same function?
Yes, that's another function. Yeah.
Okay.
Cool. Thanks. So as I said, data science, like as I told, like data science, it's about the scientific methods and the mathematics behind it. Like everybody should learn mathematics. Like you should be good in linear algebra, you should be good in probability, and you should be good in permutations and combinations. So we have the paid course, we do teach all these things as a part of basics, because without these you cannot understand what is happening inside the lines of your Python code. See, the data science coding is very much easy. All you have to write is like 2 to 3 lines of code for a task to get accomplished. But back end of that 2 to 3 lines, there is close to 10 to 12 pages of mathematical derivations, equations, formulas, theory, lot of things there. If you get all those knowledge, then you have the real memory, like how, okay, this is how your machine is training, so you can give more type of data like this, and all those things can be done using this data science, guys, trust me on this. So let me just show you, these are the job opportunities. Now if you see, starting from 2016 to now 2025, you see the rapid growth of opportunities for data scientists, because this is something that nobody has thought of. Like, let's say this is something nobody thought like it's going to be, but like at one point, like the market is short of data scientists. It's really maybe in 2018 or 2019 you don't have data scientists to hire for companies, but now it's a huge market. The data science market is very huge, guys. You can demand salaries. So these are the skills that you require: mathematics, machine learning, computer science, data processing, domain expertise, statistical research, and together, like this whole bunch we're going to teach you. So this is the core knowledge of the data science. So this is how the life cycle is. If you see in this, it's a never ending process. There is no stop point in this. Business understanding, and then you collect your data, you prepare the data, you do some analysis on the data, and then you try to create a model, and then you will evaluate a model, and then you deploy the model, and then again it continues. Because the business will not be the same for each and every day. The inputs will change, the real time data will change. Like if you use some data for training, let's say you take one day of data, and tomorrow something that comes up which doesn't have in your training data, then how your model will work on that pure unseen, not trained data? It gives some probability score, it thinks, that's it, but it cannot give accurate. So that's where the life cycle is a never ending process for data science. So this is something that I tell to each and every student that is going to start that they want to learn data science. You cannot get through this course if you have just attend the classes, or just if you say, okay, I have listened this class today, I have understood, and then you can go and sleep or you do your activities. No. Apart from the class, you have to spend at least 1 to 2 hours daily on the courses that you have listened, and then practice that. You have to do a lot of hard work. So learning strategy, it varies with person to person, but prepare your learning strategy. We'll just tell you the concepts, we'll just tell you uh, how this can be done, like how this can be achieved or what can be done. But it's the you who has to decide on how you want to take all the things from us, and in addition to this, what is the effort that you're going to keep to learn this thing. And trust me guys, lot of patience is required. You will feel something like, oh my god, what is this? I'm not gonna do this, I cannot do this. If you give up on yourselves, this is not the course that you have to pick. You should have courage and patience to listen, because there is a lot to learn. This is like a world, AI world. And if you once you step into it, it will drag you like anything into its core. And it's the most dangerous tool, and it's the most useful tool. You can use this in both ways. You can destroy the world, you can recreate the world. AI can do anything, it can do both. But it's how you use. There are a lot of things like for usage of AI, there are some ethics for data science. It's one vast subject in masters if you are picking masters in data science and engineering. So this is it. I wanted to tell you on the prerequisites and the technologies that I'm going to tell you on this course. So any questions still here? I just wanted to understand, like, are you guys good? Like whether is it fine, my voice, or like the way that I'm teaching, is it good, or like the pace, you're able to get that pace or not? Like I just wanted to know. Just keep some message in the chat, like is it good or not, or you want me to slow down a bit, or you can, is this pace is fine, or you want me to uh, tell in a faster way. Is like I just want something to start my next topic on importance of Python and its applications on data science. So it's just a quick topic. I won't take much of your time, but I just wanted to ask you. Just keep in the chat if you don't want to unmute you. But I just wanted to know, like, is it okay, fine, good, bad, something? Come on, guys. Come on. Manisha said yes. Thank you. And then someone is giving me thumbs up. And okay, what happened to the other? Ernest, Frank, Ibrahim, Oklade gave me thumbs up. Thank you. Akshat, Vinod. So anyone, guys? Anyone? Okay, cool. I think it's fine for everybody. So 1 second. So I'll just tell you, Python is like a popular high-level programming language, and it used in various applications. Like, see, if you pick cybersecurity, Python will be using. If you use application building, app building, everything, Python is key, guys. So it's an easy language to learn because it has a simple syntax, and uh, let's say if you want to do more complex tasks like machine learning, or if you want to do something like just a print statement, so it can be done. It can create, it can destroy, both the things. So Python is something that it will it is something that it's very much easy. Like, let's say if you want to write a print statement in C language, you have to write close to 6 to 7 lines of code. If it's for Java, for one single print statement you have to write close to 6 lines of code. But whereas in Python, one line, just one line, guys, only one line of code in Python. See, just one line. And if you see, this data types and operators are there in each and every language that you pick. But when it comes to Python, these are simple. Like if you see int, float, int is for the normal numbers, float is for decimals, list, tuple, string, set, dictionary, floating set, bool. So these are all the data types. Like I'll be going in depth of each one, what is what in our paid course, but I'm just telling you, like the data, these are the data types that, what are data types firstly? Data type is something that if you have some data to store, based on the type of data, you have to store that data into the specific class. Like if it's a number, you're going to store it in the class int. If it's a decimal, you're going to store it in the class float. And operators are something that carries computations like the max, like plus, minus, into, divided by, operand, greater than, less than, greater than or equal to, less than or equal to, not equal to, in, out. So these are all the general as we speak operators. Like let's say the basics of like how we speak. So that's the basic operators that we have. These are the common data types and the basic operators. So if you see, this is so to get an input function from a user. Let's say to get an input function from a user, all you have, all you have is just say input, enter a number. But if you take any other, just try to compare this syntax with the coding language that you have done. And just raise your hand or just unmute yourself and speak. Okay, in this language, for this operation, it will take lesser than this Python. I'm gonna give up my job and I'm keeping a straight away bet. So be it any operation, your Python has the simplest thing. See now the input thing, it can be done in one line. In one line, it's done. The same way print function, just say print, see, print and input, anything but one line and simple English. If you want to print y, I want to print y, then what is the code that I have to write? Print y, that's it. If I need to input a number, Input, enter a number, input number. So whatever you speak that you write is Python. It's a very much basic syntax. Like if you see basic syntax like my string hello world, my int 7, float 7, my list. If you see this same code, let's say to store this, no, you have to write something called like string, my string hello world, int my int 7 or int my int colon closed and then my int equal to 7. So you have to declare a variable that is of which data type. But in Python, based on the data that you're giving, your variable will take the data type automatically and dynamically. You don't have to specifically mention, okay, boss, in my string, you have to keep only string. No, if my string equal to 7, then my string data type will become int. So based on the value that you're storing, my variable is going to take that data type. So that's the beauty and the basic syntax rule. If you say function, see define, I have to define a function. So define function and then you have to write a lot of logic and then my function should return this. So return this. So basic English, guys. I'm going to tell each and everything what is A, what is B, everything in detail. So, but I'm just going to tell you the basic stuff. So if you want to call a function, so see, I have defined a function here. Okay, now I want to call a function. So my function, and then see, I just give one line and it is calling this function. Now this function will come here, a equal to 1, b equal to 2. It's a 1 plus 2, 3. So now my value becomes 3. Guys, you're all with me? Guys, understanding? Hello? Guys,
Please can you take that again, please?
sorry?
Can you please take that again? Calling that function.
Okay, let me retell you that. So you mean what I meant to say is like if you want to define a function, the syntax, I'm just telling you the syntax. Syntax means DEF. DEF is a short form of define. So define function a comma b and then just return a plus b. So and now if I want to call this function, so I just write function a comma b. So now this one, my function 1 comma 2 will go to here and then my a will become 1, my b will become 2 and then 1 plus 2 3. So now my value will have a value of 3 because my function is returning 1 plus 2.
Yeah, makes sense. Makes sense. Thank you.
Cool. So no. So there are different things like variables, objects, class. So variable is something that we store a value in the computer memory. Like let's say a equal to 2. Now a is a variable. Okay, so now a, when you say a is equal to 2, the data type of a is what? It's a number. So int. So it will store in its integer category. So objects are something, object is something, it's a collection of data. And class are something, it's a group of objects. So just don't get confused. So variable is a single thing, a or something. Object is group of variables. Class is group of objects, which in turn group of variables. So all variables are objects, obviously. So this is how you're going to like deal with or let's say define with. So 1 second. So this is what if you see, I'll just tell you, this is a class car. Now Polo is a car, Mini is a car, Bentley is a car, BMW is a car. So I am referring all my objects into one class because everything is a car. Car is a class. But if you see, my instances are different. Like one has pink, one has red, one has blue. So the objects are changing. Inside the object, the variables are changing, but the class is the same. So that's why the class is a collection of objects, and objects are collection of variables, which in turn each one of them have their own values. So just understand this difference. So this is something called object oriented programming. We call this as OOPS in Python. But to learn OOPS, it's a vast knowledge. Okay. So again, if else, like if okay, if I'm not going to that place, where else I will go? Or if not to that place, or if not to this place, then where? So it's a basic if syntax. See, I'm just entering a number, I'm having x. If my 2 by 2 is equal to 0, then I'm saying it's an even number. Else it says the number is 0, or else this is an odd number. So there are only three cases. Either you can go to A, or you can go to B, else you can go to C. That's it. So based on the number of classes that you're having, or based on the number of actions that you're going to take, you have to have if, elif, nested if. There are a lot of things inside this. So wait, what else? So this is one more loop. So these are all like if else, for loop, and while loop.
Sorry, Tanmay. There is Ernst who is wanting to ask a question.
Yeah, oh, sorry, Ernest, please go ahead.
Thank you. I was wondering if you could go back 2 slides. There's something that I just needed to, yes, on the slide. I don't know, I was just trying to follow through how you define your classes. That my mind is battling with the concept that how would I differentiate between a class and a schema? If because I'm looking at the way that you explained it, yes, I can reconcile with that, but then I'm having trouble with the example that you have given me.
So like you want to know class, and what is the other thing that you used?
I just want to know the difference between a class and a schema, because I don't want to find myself, using the wrong terminology, because as a software engineer, there's certain things that you shouldn't, be confused about. Because like from what I'm seeing, it almost looks like, to me, it almost looks like a schema. Yes, of course, there's an instance, but then I want to be, really sure and distinct about it explicitly, when particularly, let's say
schema. No. Let's see. Let me tell. I got your question. So schema, it's, I think you're a DBI. So if I want to put it that way. So schema is something.
Yeah.
Yeah, I got the question. So let's see schema. If I talk about schema, it's like the structure of database. Like it has, or like let's say you have data, tables, fields, everything. But classes, it's like a blueprint. If I have to keep, it's like a blueprint on which you create objects, or let's say instances with specific attributes. And each object has its own behavior. Like if you see, Polo runs in one way, Mini runs in one way, but let's see, there are manual, there is an automatic car, there's a manual car. So there are different things. But with a schema, it's a structure, it's fixed, it cannot extend. Or let's say whatever the rules that you are going to add in the start of creation of a database, that is finalized. If you want to do something, you have to go and change the schema. But when it comes to the OOPS, you cannot come to the class every time and then you have to change the class. It's like you can create a new object. You can change something. You can change your thing in this object itself. So that's the major difference, if you can see. Did I answer your question?
I would say kind of, but I'm still. I think I have to revisit.
Both are different. I mean, let me put it this way. Both are different. Let's say class is something. It defines objects. It defines objects with. It defines objects with attributes and methods. But whereas schema, it defines database structures and relationship. And if you say class is single level program, it's a code level. But whereas schema, it's a multi application. Like they can use multiple mul, mul, um, it's a multi application, right? Like many applications can use the same database, but whereas in class, like many applications can't use the same class. Each application has its own class, each application has its own objects, each application has its own instances. But whereas database, if it's the schema, multiple applications can use it. And okay,
Yeah,
and
I think
yeah.
yeah, I think the reason why I was asking that is because when you're creating a database, you do specify the instance. So like probably I was trying to reconcile the instance that you're creating when you're actually constructing or architecting your database, and then when you're creating a schema, it's yeah. I think I need to revisit my knowledge base.
Good. And see, Oops is something, it's a programming language, like you can use Python, Java, everything. But whereas schema, it's only for SQL, or it's only for database specific. It's a pure database language. And in class, in class, if you see that it depends on the what is the behavior, what is the property of the objects. But in schema, the focus is mainly on what is the structure, what is the storage, and how do you retrieve. So that both are different things, like each thing in its own area, to be precise. Okay, you got your answer?
I'd say for now, yes, but we
Okay,
can. It's just that we can debate, and it will take a long time. So I'll just. I think for now, I'm okay. Okay.
cool, so cool. Okay.
So Ernst, you can think a car like it is in technical term, it is a class. But when you say a car can be so object-oriented programming, you have inheritance. You can embed an object within another. So you can have a class with an embedded object, and that object, the very nature of that object can keep on changing. Let's say you have built a car with a automatic steering. Okay, the same car can have a manual steering, a manual power window, or a manual window, and the other model of a car can have a power window. So what you are doing, basically, you are having the class, but you are you are giving an extension to that class, having a different kind of an object embedded. So the
Oh, so basically, it's an inherent
inheritance,
sorry,
there are
yeah.
multiple things. There
Oh,
is
Multiple
okay.
things basically. Yeah,
polymorphism. So once you
polymorphism.
Oh,
define an
yeah.
object, those object oriented concepts come into picture. That is your polymorphism, your inheritance, your extend. You can extend a class. Whereas with SQL data structure, which is sort of a fixed, as was Tanmay was saying, you cannot extend it.
Yeah.
It becomes very inflexible. Whereas class, you are embedding a structure. Say I have a name. Okay, my name can have a first name, middle name, and last name. So what are the first name, middle name, last name? These are the objects. Whereas my name is a class. So another person can have the same class name, but with only the first name and the last name. There is no middle name. But in the structure of that class, middle name is also an object, but that is, or you can say a attribute, but that does not have any value. That's fine. But then I will say that that person or that class does not have a middle name. But will that class change? It's because the class is still a class. You are defining or you are adapting that class, you're extending that definition into adapting various. Uh, I mean, are you getting it? So
Uh,
you have a
yes,
class
yes, yes.
called cycle. Okay, cycle. So this cycle has some properties. It can be a manual, like without a motor, a cycle, and there can be a motor embedded. So then it becomes a motorcycle, but the class remains a cycle, let's say.
Okay.
So there is an ample scope that you can polymorph, you can extend, you can inherit. So there is a parent-child relationship, you know. So that way there is a lot of analogies that you can carry on. Did
Okay,
I?
okay. Yes, yes. Now I think I understand it now. I understand it. Thank you.
Yeah.
So,
Thank you very much.
Thank you.
yeah. Thanks, Debashish.
Sorry,
Thanks for
Tanmay,
that.
to have
Yeah, no. Thanks for that. So that's all for it. So now let me tell you a Python for data analysis. So I mean, the importance of Python for our data science. So if you see, there are multiple things like how do you read the data, how do you select and filter the data, and how do you do data manipulation, sorting, grouping, rearranging. I think Ernest, you can relate it now. The almost all the tasks that we do on an SQL DB, like grouping them, selecting them, applying filters, everything can be done using Python algorithms. And then you can plot the data, you can do some descriptive statistics, inferential statistics. Like there are a lot of things that you can do with Python. So the main tools are, like, say, NumPy is nothing but numerical Python. SciPy, it's a scientific Python. Pandas, it's a data frame, like how in SQL. Scikit-learn, it's for the machine learning. And visualization library is something, matplotlib plot library. So it's a plotting library. Seaborn, it's a plotting library. And there are many more libraries that are there, especially for data science. So if I wanted to go for some small things, I'll just show you. So if you see, NumPy is something you have to deal with arrays, vectors, vector multiplications, and addition of vectors, like let's say division of vectors, and like slicing of vectors. Because to perform, like let's say if you want to calculate mean, you have a lot of data. You want basic mathematics, you want to calculate mean, median, mode, like let's say GM, like these all basic statistical things and all. In Python, this NumPy can do. All you have to do, right, is like np.mean, in open the bracket, close the bracket. You just give the data and it will tell you mean of these numbers are this. And if you give two vectors and you wanted to multiply, you have to do a lot of homework. No, like let's say 1 to 1, and then you multiply, you add, and then you create a matrix. But you just say np dot vector, and let's say you have a vector A, vector B, just say A into B. It do np of A into B. It's going to do. So no worries, I'm going to take one whole 2 hour session on this NumPy and 2 hour session on pandas, just to make familiar with the libraries, what, like how you can actually play with the libraries and all those stuff. So see, again SciPy, it's built on NumPy, like for the linear algebra, differential equations, numerical integration, statistics, and many more things. So, and then pandas, it's like the data structures and a tool, like let's say table like data, like data aggregation, manipulation, sorting, merging, slicing, selecting, grouping, like how we do tasks in SQL, like let's say select star from a data. We just say panda pd.read underscore csv, and then you get all. Select only top 5 rows from this data and say pd.head 5. That's it. So each and every SQL operation can be done using Python. Like you have to play with, if you want to play with your data, you have to know pandas on your tongue. Yeah, it should be the structures, everything is on the on the fingers, let's say, to be very precise. So this is what pandas do. And then scikit-learning is something, it's the machine learning algorithm. Like if you want to perform classification, regression, clustering, model validation. So all these things the scikit-learn can do. Scikit-learn is a toolkit basically. Scikit is a company where they have built this tool to perform all these things. So instead of, say, because classification is whole like a mathematical formula derivation, regression is also same, clustering is also same, but They have kept all these formulas, everything in this scikit-learn, and then they have provided these applications. So all you have to do is like just import them and then use it. So that's how I mean that's the how you're gonna use scikit-learn for our data science and all. So next one is matplotlib. So see, if we talk about data visualization, we have, if you go to Excel and if you create a data, create a pivot chart, and then you can create lot of graphs like pie chart, bar chart, many things. So all those operations can be done using this matplotlib. Even you can do pivoting using pandas, and then using matplotlib you can plot the graph. So it's all related to that single library where it provides lot of features. All you have to do is like plug in the data and play with the library. Just play with the library. Trust me, it's beauty. Like it's much more interesting than any other thing. Like all it is like if you code like this, it'll come one way. If you code the other way, it'll come the other way. So you have to play with it. Like you can do line plots, scatter plot, bar plot, histograms, pie charts. It's basic things, but you can create advanced visualization as well. Just like how in Excel, if you write much complex formulas in Excel and then you create a variable and then you plot a graph. So same thing can be done in Python. Whatever the tasks that can be done in Excel or in SQL or in NoSQL, DB query, anything can be done using Python, NumPy, Matplotlib. These are the three major libraries that can do your job. I'll just tell an interesting story. I don't have much experience in Excel, but there was this one day. There's this client gave me an Excel, and he wanted me to do all these changes and give he want an Excel in return. So to write formula, I have to go to Google Array how to write formula because I never familiar with Excel. But what I did, uh, initially I started trying to do in Excel, but it is taking a lot of time and then it's hearing here and there errors. What I did, I opened my Python library, I mean Jupyter Notebook or a Visual Studio Code, the Python intelligence, like the softwares that we can write Python. I loaded that CSV file. I did all the operations that he wanted to using Python, using the pandas library, and then created graphs using matplotlib. And then at the end, I converted that all the features, everything, I converted it back to the CSV file. So now my CSV has an updated file. And then I opened another sheet, took the screenshot of the graphs and pasted it there. Job done. Simple. He gave me one full day to do it. I just did it in 1 to 2 hours using the Python. That's how the beauty is with Python. And Matplotlib, NumPy, Pandas. These are the major libraries that we're going to take care of. Seaborn, it's an another level of matplotlib. Let's say high level statistical graphs, like there are box plot, which will tell you are there any outliers, or like ggplot to say, okay, are these like having normal distribution or not. So there is lot of mathematical statistical graphs. So for those advanced things, see, those can be done in matplotlib also, but matplotlib take 5 to 6 lines of code, but whereas Seaborn can done in 2 to 3 lines of code. So it's a built on matplotlib. It's based on matplotlib. So Seaborn and matplotlib 2 are the plotting libraries. Pandas and NumPy, these two are our data manipulation, aggregation, collection, exploration. For everything, these are the two main libraries. Just for visualization, we have matplotlib and Seaborn, and for model building, we have scikit-learn. So I think I covered all the things that are there in the life cycle that I have shown to you guys, I hope. So see, we can select the Python version. Like let's say you can have Python 3 with Python 3.10. Now it's 3.12 is loading, but stable version is 3.10. So you can, based on the first step to start our coding is this, select the Python version. So you have to select the Python version first, and then you create your environment, and next you install all these necessary libraries in the environment, and load the files into the environment, do all the analysis using the pandas numpy, and do some visualization using matplotlib and seaborn, and then use scikit-learn to develop a data science model, and then use scikit-learn metrics to verify whether do the model evaluation, and then you can go for DevOps guy to ask the model to deploy. So this is how a data science task can be done. Yes, it's not as simple as I say, but it requires some serious dedication and serious interest and serious work. This is the especially this course is not something that you can learn on a fly or you can learn or a go. Okay, I have a question here. Which is the best environment to use for this AI coding, Visual Studio Code, or Jupyter Notebook? Both you can use. That's a very good question, Akshat. So you can use Visual Studio Code, you can use Jupyter Notebook. These are the two different softwares, but both does the same job. But trust me, a real data scientist guy loves Jupyter Notebook. Even I personally love Jupyter Notebook to code because it's a web UI. Visual Studio Code is just a software. But Jupyter Notebook is something, it's a web UI, and then it gives different cells. But the same Jupyter Notebook, you can open it in the Visual Studio Code as well. That is also there. But just create an environment, open a Visual Studio Code. In that, you can install n number of libraries. No need of creating environment also. So that's the beauty of Jupyter Notebook, but both can be used, and you can create Conda environment instead of virtual environment. You can create Conda environment. Anaconda is the major software that we use for data science. So Anaconda provides a Conda environment. So this all I'm going to show live, like how you can install everything in the paid course that I'm going to take then after the 4 weeks webinar session. So that on a fly. This is what I wanted to cover for today. I hope I have made myself clear on all the topics and just a basic quick introduction on what is all this. So I'll be expecting some questions from you guys. Any questions? Yeah, Ernest, please.
Yeah, thank you. That was actually an interesting presentation. I'm pretty much interested in data science now. I just have a small question because
Yeah.
you know, in other disciplines in software engineering, we always speak about time complexity and space complexity. I'm just wondering that seeing that we're speaking about mathematics and statistics and even in data science. So is that something that as a data scientist you want to take into account whenever you're building your program?
No, no, because data science is something it requires lot of computational work. See, sometimes your own CPU is not sufficient to train a model. You require GPUs, graphical processing units. So how much you write, like let's say you are a pro coder in data structures and algorithms, even then uh, to load 1 GB of file, what can you do to optimize it? You have to write one line of code. Time complexity is dependent mostly on the files that you deal with in data science. So that's where people who learn data science, like people who say deploy, because even for the deployment stuffs and all, even myself, I have seen people, if they are deploying some data science application in the normal Kubernetes cluster where normal applications are being deployed, the space is not sufficient for them. They have to increase the RAM size, they have to rebuild the virtual machine, and then they have to deploy it, because just to store a model itself, it will take a lot of space. So the data science models are like that, because that's where people mainly deploy these in the cloud infrastructure, because it's scalable, and it's a pay as you go, right? So that's the subscription that they're going to take for data science. And the models that we're going to save, we save in .pkl files. So based on the type of data, the model size, sometimes it varies from 1 GB to 5 GB. So you have to keep this 5 GB file in your machine where you deployed it. So and then you have to load that model once, and then whenever the input request comes, you have to hit that 5 GB file and then get the output. So it doesn't really matter. But one thing that you can do is like the functions that we write before and after uh, is where you can reduce your time. You can use your data structures, algorithm stuff to reduce the time complexity and all those stuff.
Yeah, I think the reason why I'm asking is because if we don't take into account that, then what guarantee do we have, or don't we put into place that we have to consider the end user so that they have a good experience when they're using that, or it is just simply for executing the task and I don't know. I'm just thinking out loud. I'm sorry.
No, that's cool. That's what the data scientists should have. They should think out of the box, and I appreciate that, Ernest. Like, but that's how the fact is hard, but it's real. So, any other
Yeah. Okay.
questions? Yeah, thanks, Ernest. Guys, any other questions? Someone is on hold. Oh my God, Isra, Biraj, someone, Talsan, Vinod, Akshat, Ibrahim, Okulade. In any questions, are you guys good with my pace, everything? Just give thumbs up or just give some message, guys. I'm just wondering what is happening. So still no.
No,
Hello.
I think they're still digesting data science.
Trust me, I didn't even teach you the Hello World program of data science. Trust me, I haven't taught you the Hello World program. Like, let's say if you're learning something, the first one they'll teach is Hello World, but that itself I haven't taught you. Trust me. So, guys, all good? So, we'll meet next week then.
So Tanmay, what will be the next week's topic?
So next week, as I said in the start of this conversation, we are going to dive deeper into the machine learning and deep learning. What is inside machine learning? What is inside deep learning? And what are the real world applications of that? And what are what are the major use cases of that? So we are going to dive deeper into those next week.
Okay, okay.
Yeah.
Guys, do you have any other question, or we can switch to our DevOps session?
Cool, guys. Then see you guys next week. Thanks, Christ. Thank you. Gal.
Thank you,
Thank you,
everyone.
Vinod.
So we
Thank
have,
you.
Thanks, Justy.
Thanks.
I think we have one more session after this. The same link, same. Those who wants to join the DevOps session, just wait here because the Mr. Devashish is there, but the session is supposed to start at 10. So we have 15 minutes. We can, do a little chit chat or